Let's take a journey into the realm of science fiction and explore the fascinating question. What if we could travel faster than light? First things first, what is the speed of light? It's approximately 299,792 kilometers per second in a vacuum. This universal constant is often represented by the letter c in physics. Nothing can travel faster than this speed, because that would violate the fundamental laws of our universe. Or can it? Why do we think nothing can travel faster than light? In the early 20th century, Albert Einstein developed his theory of special relativity, which revolutionized our understanding of space and time. One of its postulates is that the speed of light in a vacuum is the same for all observers regardless of their relative motion. This means that no matter how fast you are moving, whether it's a rocket ship or a beam of light, if you were to measure the speed of light, it would always be 299,792 kilometers per second. This is not just a quirky rule of the universe. It's deeply ingrained in the fabric of reality. The idea that nothing can travel faster than light has profound implications. It suggests that there are fundamental limits to what's possible in the universe. And yet it also sparks our curiosity about what might lie beyond those limits. Einstein's theory of general relativity tells us that space and time intertwined in a four-dimensional fabric called space-time are flexible and can be warped by massive objects like black holes and neutron stars. While these celestial objects can warp space-time around them, they too are bound by the speed of light limit. Nothing, not even information or matter, can escape the gravitational pull of these collapsed giants once they cross the event horizon. This means that if we were to travel faster than light, we would be venturing into uncharted territory where the rules of physics as we know them may no longer apply. As we approach the speed of light, time slows down for an observer relative to someone who is not moving at that speed. This phenomenon known as time dilation was predicted by Einstein's theory of special relativity. If we were to travel faster than light, we would essentially be traveling into the future. At the speed of light, time would effectively stop for the traveler. This means that if we were to travel faster than light and then return, we would find that significantly less time had passed for us than for those who remained stationary. This could potentially allow us to travel through time, albeit only into the future. Faster-than-light travel is often depicted in science fiction as a means to explore distant galaxies and planets that are many light-years away. This raises the intriguing possibility that if we could travel faster than light, we could potentially explore these distant regions of space almost instantly. However, such journeys would require us to navigate the complexities of wormholes, hypothetical tunnels that connect different points in space-time. While the concept of wormholes is mathematically possible within the framework of Einstein's theories, their existence remains purely speculative. Some scientists believe that wormholes could be created artificially using advanced technology. Others think they may occur naturally in space. Despite the uncertainty, the idea of wormholes continues to captivate scientists and science fiction enthusiasts alike. Traveling faster than light is also associated with the concept of warp drives, a theoretical concept that involves distorting space-time around a spacecraft to enable faster-than-light travel. Warp drives have been popularized in science fiction, most notably in Star Trek, where starships use warp drives to travel faster than light. However, warp drives remain purely theoretical and face significant challenges in terms of their feasibility and the energy requirements to power them. One of the most perplexing aspects of faster-than-light travel is the issue of causality. The idea that cause must precede effect is a fundamental principle in physics and our everyday experience. However, if we were to travel faster than light, we would be able to travel back in time. This raises the question of whether we could potentially violate causality by, for example, going back in time and killing our own grandfather, which would create a paradox since we would have been born if our grandfather had died before we existed. Physicists have proposed various solutions to the causality problem, such as the Novikov self-consistency principle, which suggests that any actions we take while traveling faster than light would be consistent with the initial conditions that led to our arrival at that point in time. Another major obstacle to faster-than-light travel is the immense energy required to propel a spacecraft to such speeds. As an object approaches the speed of light, its mass increases, requiring an infinite amount of energy to reach the speed of light. This means that building a spacecraft capable of traveling faster than light would require a nearly impossible amount of energy. Currently, our technology is nowhere near to being able to achieve this. The question of whether faster-than-light travel is possible has fascinated scientists and philosophers for centuries. Some believe that it could be possible with advancements in technology or a deeper understanding of physics. Others argue that it's simply not possible and that the laws of nature are fixed. What do you think is faster-than-light travel possible? Let us know your thoughts in the comments below. If we were to discover a way to travel faster than light, it would have profound implications for our understanding of the universe and our place in it. It would challenge the very foundations of physics and raise new ethical and philosophical questions. Furthermore, the ability to travel faster than light would open up unprecedented possibilities for space colonization and exploration. We could potentially reach distant stars and planets that are currently out of our reach, and establish new colonies beyond our solar system. However, this would also present new challenges such as the need to develop sustainable life support systems and the potential impact on any indigenous life forms we might encounter. Overall, the prospect of traveling faster than light is both exciting and daunting. It's a tantalizing possibility that captures our imagination and drives our curiosity about the mysteries of the cosmos.